Right, welcome back to the channel. Sorry about the background noise, it's a very warm day today, experiencing a little bit of a heat wave here in the UK, and we've got another NI440DX, and this one has intermittent transmit. Mentions the tone dial, which I assume the viewer means the dial here, erratic signal meter, and he wants a tune-up. This was sent to me by one of my viewers, Dave, who's had this from new, and has been experiencing a few problems with it. So let's just power it up and see what it is and isn't doing. Right, on powering up, we appear to have a functioning audio. So we've got our white noise, we've got our RF gain up to maximum, and all our switches in the lower position here, and they all work. PA, the Rog beep, and channel 9. So let's see what we're getting when we go into transmit. Okay, so I can hear the relay clicking, and you can see the RX light going out, but we're getting nothing on the meter, and we're getting nothing on the actual power meter. So it's not actually producing any power at all. Now let's get the Randy out and see if we're actually getting any transmit at all. So we've got the President Randy, and we're not getting any transmit whatsoever off of the radio. So even though I can hear that relay clicking, can hear it inside, it's a bit loud. The AC is a bit loud at the minute, but now it's one of the areas where these can be a little bit weak, although this could also be that the VCO is set incorrectly, or it's been adjusted, or it's moved. So the first thing I'll check on this is the VCO, but let's just check what it's like on receive. Right, so on receive it's doing a very, very healthy 0.35 microvolts, so absolutely no problem on receive. Now on these, I have seen on the NI440 or the Sapphire based rigs, is when that relay is dodgy, if you just tap the radio you can lose receive, but we're not getting that. I think the first thing we'll look at is the VCO for transmit. It might just be as simple as that, and there is a method for checking the VCO. Right, the first thing to do is to gently tap on the relay while we're in transmit. So we're in transmit now to see if it is a contact issue. Sometimes when these are intermittent, that will bring it into transmit. Right, to check the VCO voltages, you're on the LC7137. You want to go off of pin number 17. Set the radio for channel 40, and then you're looking on receive for about 2.5 volts on receive and 3.2 on transmit. So we know receive is working, so let's just check that. 20, 19, 18, 17, fourth pin down. Just make sure we're on that. 20, 19, 18, 17. You can see there we've got 1.9 volts on receive, so it needs to come up a little bit, but when we go into transmit you'll see we're not getting anything there. Now the adjustment for the transmit VCO is on CT1, which is the little yellow trimmer capacitor just down there by my finger. So we'll give that a little spin round first, just to clear it of any dirt and debris, and then we'll see if we can bring it up with that. So there's CT1 down there, the little yellow trimmer, and we can't get any adjustment off of pin 17. It's not varying the voltage at all. So I'm going to have a look at the circuit diagram to see how relevant that is to the relay, but I will actually just check the pin connections on the relay to make sure that when this goes into transmit that they are closing. Right, so if you look at the wiring diagram here for the relay, in receive, in the normally closed state, receive is on. When you press the PTT, it grounds the receive line, and then it puts your 8 volts on the TX line, but we're not getting that. Even though the relay does test properly out of circuit, we're still not getting it. So what I've done is I've disconnected the ground line, because they're coupled up on the normally open and the normally closed there. Disconnected this point here, and if I bridge these two contacts, it should go into transmit, if transmit works. So I'll just show you that on the radio. It's a bit dim as it always is on these, but the RX light is on, and what we'll do now is I'll bridge these two contacts. So the two contacts you want to bridge, bear in mind you must only do this if you isolate that point there. So we've isolated that pin there, which is the ground pin, okay, and if we short these two it should go into transmit. There you go. You've got got power there, and we got the transmit light on. Okay, so that's pretty definitive that although that relay does appear to test okay, it's not switching. We're not getting the signal through, whether it's just a poor contact or something, but they are an absolute pain on these. This is the fourth one where I've had an issue. I think Mick's one that I've just done for him, I think, has developed the same problem. So it's worth changing these, I think, if you've got one of these of that kind of interest, because it's not a question of if it goes, it's when, really. Right, we've got the relay hooked up now to the bench supply. I've tested the one side of the relay, which is okay. Now we're going to test the other side of the relay, which I know to be faulty. So the closing contacts of the relay should represent about 0.2 of an ohm resistance, something like that. And this is on the transmit side of the relay, and what we've got here, we've got the blue probe on the common of the relay and the yellow probe on the normally open contacts. So now we're going to energize the relay and check what that resistance is between the contacts. So the relay is coming on now. You can hear it click, and we've got 10 ohms. You see that, and you see it's fluctuating as well, so that's not good. The other side doesn't do that. I'll just show you the other side as a comparison. Alright, here's the other side connected up. Blue probe on the common, yellow on the normally open. Press the energize the relay, and we got 0.4 of an ohm. Still a little bit higher than I'd like on a new relay, but that's absolutely fine. And that side is working, of course. That's the receive side. So that we know that this relay is faulty. Now I know some of you will say, well, you can get a replacement relay. Yes, you can get them. They're £10, and that's a lot of money for a relay. You can get 10 new relays for the same amount of money, and of course they're not very good quality relays. They're still going to be a 40-year-old relay, so you know, you can put a new one in. But how long it's going to last, I don't know. Right, I think what I'm going to do, in the past I've wired these to pins in the board with wires going off the relays and stuff, which is fine when it's my radio. But when it's someone else's radio, I think I need to do something a bit better than that, a bit neater. So what I'm going to do, we're not going to spend £10 on another one of these relays that might fail. What we'll do is we shall 3D print an adapter. So it will be an adapter piece that I can connect this into, so it'll be slightly taller, but that doesn't matter. It will sit within it, and then I will crosswire the pins over and crosswire the pins over inside with some link wires, and then we'll have a standalone relay that will fit within that gap, so it'll look a lot neater. It'll actually fit exactly where the other one went, albeit just a little bit taller. Okay, so I'm going to do that. I did think of getting a socket to put this in, but I don't like socketed connections. Every time you get a socketed connection, you got the possibility of getting a bad joint and a bad connection. So I decided, just if I 3D print something, I can make it, print it, sit this within it, quickly wire it up. It shouldn't be too bad. Just wire it up and then pop that inside the little adapter, and then the pins on the underside will all be exactly as this one, but with a little bit more reliability of a modern relay. Of course you can spend a bit more money on the relays. These are Chinese relays, but I'm sure these will be absolutely fine. And you could get Finder relays or whatever, something a bit more expensive, but then you start getting into the realms of a lot more expense, so you don't want to be throwing tons of money at these. And of course we're not doing anything permanent in terms of cutting tracks on the back of the board or anything, so it can be put back to totally back to original. If the owner wanted to get some of these at expense and have them and replace it, it's a fairly easy job to do with a soldering iron. So nothing permanent, but it's going to work a lot better, I think. So I'll have to get on the design software, see what I can come up with. We'll 3D print it, I think. Which should be just about good enough. It might be borderline on resin printing, but we'll see. And then we'll come up with something. So it's going to be a bit of a pause. You won't notice it, but hopefully I'll come back with something that's going to work. Okay, so what I came up with was we need to offset the relay. You can't stack it too high up because it'll hit the speaker cone inside the radio. So the idea I came up with was to sit the the new relay, the orange relay, upside down like that in that part of the relay case, and then using these inexpensive header pins and wires, the type of thing that you can get for Arduino connections, just to drive those in through that plate and secure them with just a little dab of epoxy on either side of the pin there, just to keep them in place. And these come with wires already fitted, which we can then just very quickly connect up, solder up to the pins on the relay, and then over the top of that we can pop a case like this. And with this case, what we need to do is leave a little gap under there for a wire to connect up this side of the board. You'll see when I present it to the radio. So this was the general idea, to do this, and then that way it makes a completely standalone module. Took about 20 minutes. I've actually already made this as I'm recording this. It took about 20 minutes to manufacture, so not too long, and quite enjoyable really, and of course reusable too. So you know, if you was a real chin wagger and you was on your radio all the time, you could swap out that relay with no problems at all. So let's see how this thing looked when it came off the printer and how it looked when fully assembled. Right, this is a little bit of a prototype. I might change the design, but I'm pretty pleased with it, how it's coming out. We can pop our pins through the base of there. We've got a little case to go on top of it, and we should better solder sit the relay inside the cap there on this side, so the relay will go upside down and sit inside the little cap piece there, and then the lid will slide all over the top of it all, so it should work all right. Printed off a little label for the front of it. Like I say, this is a bit of a work in progress, this one, and we'll see how it works. It'll just look a bit tidier than I think setting it off with wires to the side. If we can get it all under this little lid, that'd be good. Right, we've got all the pins in there. I just popped a tiny little bit of epoxy in there just to stop the pins from moving around. We'll just snip these wires, get these wires snipped and tinned, get them soldered up to the relay, and pop the cap on and stick it in, and we'll try it. Right, there it is, all wired up. Didn't take it too long at all. And the nice thing about this is, of course, you can, you know, if you have a problem with the relay or you want to put a super high quality relay in there, you just unsolder the wires and drop one in. I didn't sleeve any of these because there's going to be a case going over the top of this, so yeah, that's good. So it's more of an adapter really than a permanent relay. And there you go. I'm going to say this is the prototype. I have changed the design since to incorporate a little bar that slides under there to keep the clip in, so we don't have to hot glue the base of it in. That'll just make it a bit tidier. But you do need that wire, you do need that cut through there because there's a wire that needs to run underneath the relay. That yellow wire there on the board. So that's what the little cut through is at the back. So yeah, that's a goer, I think. Just drop it in the radio, I'm sure this is going to work. And there we go, it's in there. You can see the little gap for the yellow wire under there, and that's why I stepped that side of the relay up as well, because there's also a resistor that goes across the back there as well. So and there's absolutely no room at the front here. There's a diode there, so I did change the design to make it easier for those pins to slide in at the front, but really there's not a lot of room. The new design, I've got an extra millimetre there, see, towards that front edge. I think that might be a little bit tight. I'll try it on mixed radio, because this is the slightly modified version for mixed radio. So well, but you know, this is what you do when you're prototyping things. But this one fits perfectly. That's absolutely in there, perfect. So yeah, very, very pleased. Plenty of pins to work with on the other side as well there, so that's not a problem. So I'll get it soldered in. Right, the moment of truth. We have receive. Don't have the speaker plugged in, but we do have receive. We've got our receive light on. Do we have transmit? Yay! There's our TX light. You can hear the relay. Little click, and there's the TX power. Right, we'll go and adjust the VCO now. We should be able to do that now with the little yellow trimmer down there. Now we've got transmit, but yeah, this you'll find this will definitely be your problem if you're having intermittent receive and transmit problems, because don't forget this switches both receive and transmit. So if you're having problems with receive and transmit on this chassis, because bear in mind it's this radio is based on the same chassis, the Sapphire 4000. I think there is a serial number on it somewhere. The UK 4000 PCB1. There you go. And of course, as you know, a lot of the they just changed the channel knob. There's a lot of radios that are off the same chassis, but to be honest, it's a very reliable set. This is the only thing that is not reliable, and it's not like the DNTs. The DNTs, the relays in those for some reason seem to be okay, but in these, in my experience, they've all been ghastly. So I've got 2 of these on the shelf, so I'm going to actually do this mod on both of those, because it doesn't take that long. Probably about half an hour to completely assemble that, versus £10 to buy the exact same relay that probably will be bad when you put it in. I mean, those contacts are going to be 40 years old as well, and it's not like this has seen a lot of use, I don't think. If I can get it to focus, they just aren't any good. Rubbish. Right, that's the VCO all set. Now there are a couple of capacitors which I might need to check. Can you see that one there? This little plastic is receding around the top of it, and we've also got one there as well. See that one there? So I'm actually going to take these 2 out before I do the tune up actually, and check them. And it might be worth checking some of the larger capacitors there towards the back. They're not known for it, they're not known for going bad, but when I see them, that one there as well is a little bit borderline. When I see them receding like that, I do like to check them. But I've checked this all on all channels, every single channel, transmit and receive, and it's all good. The VCOs can be a little bit problematic on these. It is worth, if you do when you're setting these up, to go through and check the blocks of channels to make sure you're getting your full transmit and receive range, because I've had varied results on adjusting it to 4 volts. I've had problems, I've had to drop it down a bit. So what I always do with the 440s is I always check every single channel for transmit and receive. Only takes a few minutes with the walkie-talkie, so it's worth doing. Right, let's get those capacitors out. It should be a 33 microfarad. It's gone up to 43. We'll change it. It's 40 years old. There you go. The replacement's a little bit more like it. 33.04. Spot on. Yeah, this next one should be 3.3. It's 5 microfarads. This is the one with the very receded top, so we should change that. Right. We knew what receive was on this. Very, very good. It was. Transmit power. Have a little look. Okay, so it's a bit low. It's just under 3 watts. Let's just see if we can bring that up to the 4 watt mark. I'm sure we can. Okay, that's brought it up to 3.5 watts. That's a bit more like what it should be. It was pretty low. Right, high-low power switch. Let's see what it does when we pop it into low power. Put it on the 2.5 watt scale. Okay, so a little bit high. It's just over half a watt. We'll bring that down, and to bring it down, according to my crib sheet, excuse me, it's that potentiometer just there on my big fat finger. And there we go, 0.4 watts. Not critical, but some people do like to use low power. Roger beep. Now you know I love a Roger beep. So that's good. Now the one quirk you get with these, even if you turn the Roger beep off, you still get a delay. Again, there's a mod that you can do for that. It's on the Blenheim diagram, but I'm not going to do it. Again, I don't want to change it. Keep it as standard as we can. Alright, TX power meter. Just take that up a slight notch. It should be bang on the 4. But actually it's at 3.5 watts. It's probably pretty accurate, isn't it? but we'll stick it up to 4. Stick it up to 4. And that's that little fella nestled down there if you need to adjust the TX power meter. Right, for frequency on transmit, that's that little yellow trimmer bottom right there. We are slightly high. If I just take you over to the SDR there, a little bit high. I'll do it on the frequency counter and we'll get that absolutely spot on. Here we go, 27,79125. Spot on. Right, do the deviation. That's the trimmer pot VR1 just down there, as you can see. It's about right. We'll just bring it up a little bit. There we go. 1, 2, testing. 1, 2, 1, 2. Right, before we move on to receive, it's a really hot day. I'm going to go and take the kids swimming, keep them happy. There's the little crib sheet. If you've got one of these and you want to know what all the bits do. There we go. I think I've probably shown you this in another video anyway. So, but that's what all of the adjustment, where all the adjustment points are for this chassis. Okay, so hopefully you can pause that and you can use that if you want to do this yourselves. Right, we'll adjust the FM detector. We've got a 100 microvolt signal on the radio. I'll just let you quickly hear that. There you go, you can hear the signal up there on the radio. Knock the signal off just to do the adjustment, and we're looking for the peak here. You can see it collapses quite quickly, doesn't it? I think it was pretty much at peak. Okay, and we're pretty much just going to go and do the receive lineup now. That was the FM detector adjustment point there, that inductor there, and we're going to go and do the receive, which is, if you can see from what they should be able to, that can number there. Start with that one, this one, this one, this one. Sometimes this is under a bit of tape, this one. And then this one here, and then there's also that one there, and then this one here. It's starting to get a little bit windy in here now. So I'm going to go through this off camera, but first, before we do that, let's just double check what we're getting on receive on the synad meter. So it's doing 0.33 of a microvolt for 12 dB synad. 12 dB synad, okay? So we've got to try and improve on that. And I'll bring you back to see if we have. It's probably likely that we won't. Yeah, I was right. I could not get it any better than 0.33 of a microvolt. So it's stayed very well well aligned in terms of receive, this radio, and I had a really good go with that. And I certainly can't get it any better than that, and I didn't think I probably would be able to. So, but yeah, that's all aligned, sounding good. So let's adjust the signal meter. We'll put 100 microvolts on the SIGGEN and then pop that out to the radio and see what that sounds like. That's what that sounds like. The signal meter adjustment is down there where my cleaning straw is. Just going to give that a little soak and then give that a twiddle, and we'll get it so it's reading 100 microvolts bang on. So I don't know if you can see the meter there. It's always tricky when you're trying to get a camera in to show the alignment, and it's see if we can get it in there. So we're just shy of the 9 now. Let's just give it a little movement. It's probably not been moved for 40 years, and there we go. We're spot on the 9 there. Right, so that just leaves the squelch adjustment, which is another one that's well tucked away in there. We'll give that a little blaster cleaner and give that a spin round. We're going to put 100 microvolts on the signal generator and then adjust that off so it comes in at full squelch. So they're going to turn the squelch up to full. It's on minimum at the minute, and you can see it's squelched out the tone already on 100 microvolts. So we don't want that. We want to bring the squelch back in. So let's give that a little twiddle. Very hard to not get my hands in the shot here, but there we go. We just want it just coming in out there. Right, okay, let's try that then. We'll leave that in there for now. Let's just reduce the signal level. There we go. It's dropping off at 95 and coming in at 97. That's perfect. So what we'll do now is we'll set it to the low end. So we'll turn the signal off. We'll turn the squelch all the way down to its threshold. That's its threshold point. And we'll set 0.5 of a microvolt on the SIGGEN and see if it comes in. There we go, it's coming in. It's coming in at, let's just wind the SIGGEN back down. It's coming in at 0.2 of a microvolt. So it's coming in at 0.2 and it's leaving at just under 0.2, 0.21. So that's very sensitive. Absolutely spot on. Perfectly adjusted squelch. Right, I haven't spotted that any of the controls need a clean. I might just give the knobs a quick clean on it. But yeah, I'm really pleased with that, and I hope you like my custom made relay. Now of course, for all of you purists out there that you know, like to see original parts put in the relay, there's nothing to stop you fitting a new old stock version of the old relay. Like I said on the video already, it's just you know, the quality of those is very suspect, and you're buying new old stock, so they've probably developed the same problem that relay has in terms of its you know, its contacts and everything, because they're not switching a huge amount of current. And I think that is the problem with these sets, is that these contacts tarnish, and they're pushing such minute current through there that it just doesn't switch properly. So yeah, so that is a good little viable option. Now as with all my stuff, what I'll do is I'll probably just refine the design. This was the prototype, but I might just knock a few of those up and stick them on eBay if anyone's interested, and hopefully that'll help resurrect a few sets. But 9 times out of 10, if you've got this chassis, whether it's a Serpent or a NI440 or whatever it is, other guys they come in, you know, the chances are that relay, if it's not already gone, it's going to go on you. So yeah, that's the full tune-up. That's done. I hope Dave's happy with that. We'll just give his microphone a quick clean, and then I'll put it all back together, and it'll probably be me and Tyler doing a little audio test with it. But I will keep it on overnight and make sure it's all working okay. Keep an eye on those VCO voltages as well, and just make sure we've got no issues there. The capacitors were dodgy. I mean, it might benefit from a full recap at some point, but I don't see that there's any physical sign of that being required just at the moment. Okay, give it a bit of a clean up. Clean the mic as well. That's come up like new. Look, that's nice and clean, all refreshed. I'll switch clean the mic as well. So yeah, it's all looking really good. Like I say, Mick is away at the minute, so we'll just do a quick basic audio test to the President Randy in the other room, and then I'll get Tyler to help me do an actual field test with the radio, and we'll leave it on soak for I don't know, for 24 hours probably, something like that. It's nice and warm, so it'll give it a good test. Test of the Communicators NI440DX, which has had a receive and transmit problem, which has been rectified by fitting a brand new relay. Testing 1 2 3 4 5 5 4 3 2 1. The quick brown fox jumped over the lazy dog. Testing the receive now on the NI440DX using the President Randy 3 just outside the house. Testing 1 2 3 4 5 5 4 3 2 1. The quick brown fox jumped over the lazy dog. Right, it's a couple of days later. It's a little bit cooler now. I'll just move the camera back to get it fully in shot. We'll see if Mick's about. Hi there, Mick. I've got another radio to test. I won't mention what radio this is until we conclude. Anyway, I wonder how you copy. It's nice that the weather's cooled down a little bit now, and it feels a bit more normal, doesn't it? So I wonder how you're receiving me there. I gather you're recording at your end.
Yeah, okay, Paul, recording at my end, and it sounds very good coming through on the
Mustang 2000. It's I don't know what you've got there. You won't tell me yet. That's the secret. So yes, no, you're good. Good audio, Paul. So back to you, mate.
Yeah, Roger D, that's good. Yeah, I thought we'd keep it secret, and we'll reveal it at the end of the test. And yeah, it's coming. I mean, you may well guess what the radio is anyway. But it's coming with a common fault that these relays have, and I've managed to manufacture a part for the inside that replaces the old component, but neatly disguises it inside a new box, if you like. So I'm very pleased with how it's working, and it should make these radios a bit more future-proof as we go off into the future with them. And I mean, it's a 40-year-old radio now, and I don't see why it shouldn't last for another 40 years, Rog.
Yes, that's good. Very good audio indeed, actually. And
there's hardly any white noise coming from you neither, so on the signal. So yes, I would be pleased to listen to that. I'll just give you a quick audio check on it. A quick brown fox jumps over the lazy dog. Back to you, Paul.
Yeah, Rog, well, you're sounding good. There's a tiny little bit of white noise on your signal from where you are. For those that don't know, Mick is about a mile and a half away down a hill. There's lots of houses in between and stuff, and I'm using an indoor antenna in the loft. Mick is using an outdoor antenna, but it's only at the sort of bottom of the garden type thing, I think. So they're not elevated antennas, but we purposely left it like that because it's a tougher test for the radios, isn't it? It's no good if they're fully quietening and there's no problems. So it actually works well for the purposes of the test. So yeah, you give this one the green light then, Mick. You think this is a goer, yeah?
yeah, that is correct, Paul. And the audio is back to the
level that I expect from you. Very good indeed, and nice and crisp, and very readable. So back to you, Paul. Yes, you've done a good job with that one.
Yeah, Rog, okay, well, I'll reveal it's an NI440DX, which I know is a favourite of yours, and this came in with no transmit, and receive was a little bit patchy as well when I looked at it, and the transmit issue is related to the relay inside it, of course, which is a known fault on those. I've had 3 or 4 of those now where this has been a problem, but to replace the relay you have to fit a new old stock version of the existing relays, which are quite expensive and also will probably develop the same fault because I believe these contacts tarnish over time, and that's the issue that you get with these. So you'd really be fitting another component that was only going to fail, whereas with this method you can fit whatever quality relay you want, and you can also replace it very, very easily simply by just removing the cap and soldering in a new relay. So you'll have seen all that on the video by now anyway. That's going up on Friday, which is today, but not really today, if you like, as we're a couple of days away. So I'll let you finish off the recording at your end, and thanks for your help.
Yeah, okay, Paul, all good. I did wonder if it was a 440 or not.
440 and not listening to the audio coming across, because it's a very good standard. So yes, you're fine. Okay, mate, I'm going to stop recording this end and pass it back to you. Okay,
thanks again there, Mick, for your help there. It's always great to get a human, a real person on the end of these tests. Really, it's sometimes you just can't hear the difference on lab equipment. Doesn't obviously discriminate in that regard. And also, as we found out on the Beta 1000s, the things like this internal speaker and things like that you needed to check, which this definitely is okay. Okay then, if you have been, thanks ever so much for watching. Got a few more outdoor tests coming up soon, now the weather's cooled down a bit. And thanks for watching, and we'll move on to something else. We'll catch you on the next one. Take care.